Good morning, everyone. Before we start, I want to thank our sponsor that made this possible. My name is Porta. I'm a customer engineer at Microsoft, and today I'm here with my colleague Tommaso Stocchi to talk about how to automate your load testing using Azure DevOps, K6, and Log Analytics. If you have any questions, just pop us a tweet or a message, and we will try as soon as possible. So, when we develop an application, there are many things that you have to keep in consideration. For example, how fast will the application code perform, and how will the application behave in front of an expected user load? What is the point of the user load that actually will break the application? And if the application will successfully scale up to expected future capacity. Each one of these questions have a specific test and activity that aim to give you the information that you need to answer and be sure that you are delivering a good quality software. For example, performance testing focuses on the performance of your source code. Load testing focuses on the application stability and reliability under both normal and peak load conditions. Stress testing, sometimes these two tests are confused with each other and see it as the same type, but they're kind of different. While load testing focuses on the application stability under both normal and peak condition, stress testing focuses on reaching the breaking point of your application by putting application under an unrealistic load. Last but not least, we have capacity planning that focuses on verify if the application will successfully scale up. In today's session, we are going to focus on the second block, which is load testing. So why is load testing important? If you live in the United States, probably this is the last thing that you would like to see. It's like a nightmare. When in 2010, the government of the United States rolled out the Obamacare individual mandate, thousands and thousands of people rushed to the website to enroll the F program. As a result, the system, which development cost was estimated around $500 to $600 million, crashed. An entire healthcare.gov website went down, making it impossible to the users to log in and enroll the program. Successfully, after that, the government started an investigation, and there were claims that the code was poorly written, never tested, and using outdated technology. And the HHS Secretary Kathleen Sebelius was also called to testify in front of the Congress to explain what happened. So here we are talking about one of the biggest reform or F program in the United States, and the entire website went down. So it was a big deal. For those of you who don't have to deal with the American healthcare system or like colorful graphs, this slide might be more interesting. In today's world, both enterprises and customers rely on digital application for crucial function. For example, we use our phone and our online banking for a lot of operation nowadays. Or even if you want to buy a new table or something from Amazon, or even connect with other people using Facebook and LinkedIn. For this reason, even a small failure can be costly, both in terms of reputation and money. Why I'm saying that? Just think about peak time. It's like Black Friday or Christmas when thousands or millions of users are using Amazon or other e-commerce to buy presents. And if, for example, these websites weren't tested and they weren't able to respond in a timely manner or even crash, that would be very, very costly for the company. You might think that this event is very unlikely. However, according to a survey taken by Gartner, a global research and advisory firm, in 2020, 25% of the respondents reported that the average hourly downtime cost of their application was between $300,000 to $400,000. Furthermore, 17% said that it cost them $5 million per hour. We are talking, this is a lot of money, a lot of to deal with. So now we know why load testing is important, but how they actually works. So on one hand, we have developers verify the actual test that the tool later is going to perform. When they start, they click on a button on the UI or execute a command on the command prompt, and the tool will start basically simulate a specific number of virtual users. Might be 100 or even millions, but just be careful. This number is like an expected number. For example, according to my analysis, I know that my number of users is going to be between 5 million to 10 million during Christmas. I'm going to use a number similar to this number, not something unrealistic, not 100,000 millions. And the tool will start sending concurrent requests to a target machine and measuring insights like response time, throughput rates, resource utilization level, and more. Once the test is over, the tools will then create a summary showing all these metrics. For example, here we have an example with K6. As you can see, this is a summary of a test of the duration of 1 minute that simulate 30 virtual users. And you can see here a lot of metrics like the number of HTTP requests blocked, how many the average duration, how many were received, how many were sent, the TSL and shaking, a lot of metrics that actually will help us understand how our website is behaving, how our application will be behaving with this number of users. So now we know load testing are important, how they work. Let's move into some tools, in particular K6. For those who don't know it, K6 is an open source load testing tool. It's written in Golang and embeds a JavaScript runtime that allows developers to actually write performance testing, load testing, in JavaScript. By default, can connect and talk to the server, to the target server over TSL. It's Docker friendly, support HTTP1, HTTP2, WebSocket, gRPC protocols, and also support check and threshold for a easy and flexible CI configuration. Last but not least, in June 2021, K6 became part of the Grafana Lab, which offers a flexible matrix, storage, and visualization. So why K6? Why are here today talking about K6? As I mentioned, there are many load testing tools out there. For example, JMeter, Locus, Feeder, and Grinder, Gatling. The list is very, very long. Well, according to a survey taken by Statista.com, which actually asked to software developers all over the world, which was the most common programming language that they used during their career. Basically, these are the results. 21% said that they use PHP. 48% Python, for example. If you think about artificial intelligence, Python became one of the most common programming language. Then we have C#, Java, C, which is very low, 21, and 64% said JavaScript. Around almost 65% said JavaScript. This number, as you can see here, it's more than 100, but because software developers usually don't use just one programming language, they use many of them. This is the reason why the total is not 100. So JavaScript, according as 2021, JavaScript is the most common programming language among software developers. It also can boost more than 1.4 million libraries. And according to Slashdata, JavaScript, CoffeeScript, and Microsoft TypeScript reach around 12.4 million developers worldwide. You might say, even if my dev team is not familiar with JavaScript, what's the big deal? They can learn a new programming language. Yes, they can, but according to the World Economic Forum, a paper from the World Economic Forum, the cost of reskilling in the United States, which include funding, learning design, training materials, and subject matter expertise, is approximately $25,000 per person. And also, this is only for the training. You're not keeping this number is not keeping into consideration the time that the dev team or the employee is not spending performing their actual work. is the time that I actually spend in learning something. So this is one reason why we are talking about K6, because it uses JavaScript, which is very common among software developers, and you don't have to spend time reskilling your dev team. But that's not only. That's not the only thing. In fact, load testing can be tricky because, especially with large-scale tests with thousands or even millions of virtual users, just think about performing load tests on websites like Amazon or Facebook when it was still up and running, or Bing.com. You have to like simulate millions and millions of users. And these users are actually generated by a machine, and a machine, like every other, need RAM and CPU, need computational power. And the problem here is, as the number of virtual users increase, your machine might suffer from a lack of computational power. As a result, you might see either that your load tests become unable to go above a certain number of requests per second, or that your response time measurement become unreliable. So your test, you might see high response time when actually the problem was your machine. To solve this problem, of course, you can scale vertically or horizontally your virtual machines, the virtual machine dedicated to performing load testing. But scaling is not free. You have to set in place the infrastructure, or you have to pay a cloud service provider to scale up your machine. So you have to pay money for it. So there is another approach that I would like to consider, which is using a tool that is less hungry for resources. And this is, in fact, K6. As you can see here in these two graphs, in the one at the bottom, the memory usage for 1 million requests of K6 is 114 megabytes, while other tools almost reach peak of 661. And by using less memory per request, actually you can achieve a higher number of virtual users. As you can see on the top graph, K6 can reach even 11.300 requests per second, which is a lot. I mean, these graphs are measurements are taken into consideration using a 4-core Celeron running on Ubuntu server with 8 GB of RAM. So it's not super powerful. And what are the results? If using K6 also, you can reach a higher number because it uses less RAM. So it means that you can use less virtual machine, or even just one. And this will make you save money. But also, it will make it easier for developers to integrate this load testing tool in their CI/CD, for example, in a pipeline that we're going to see later. Before leaving the stage, Tommaso, I just want to give a quick side note about how easy it is actually to install K6. With just one or few lines of code, you can actually set this tool up on your local machine. For example, you can see on macOS, you can use Brew. Windows, you can use Choco. You already have a Docker image ready to go on Docker Hub. And on Linux, you have it's a little bit complicated. I mean, you have just 3 lines of code, let's say. You can see it on the official documentation, and you can set up your Linux machine. With this, I finish. Tommaso, the stage is yours.
Thank you, Ivan. Let me share you my screen. Gaetano, can you confirm that my screen can be seen? Hello?
Yes, Tommaso.
Okay.
Your screen is live.
Okay, great. So I'm going to show you how to integrate your K6 load tests inside your CI/CD processes. Let's start with the super complicated program I've set up. This is basically a very simple API, someone would say minimal. You just have one endpoint, which is called fast API, which returns the hello world. This is done using the new minimalistic API in .NET 6 framework, okay, which is in preview. And that's basically it. We have a deployment on an app service on Azure, okay, with two main deployment slots. The first one is the production one, and the second one is called staging. And basically, what we do is we have set up a CI/CD pipeline to first build our code and deploy it to the staging environment first. And then lastly, we are going to swap between the staging environment and the production deployment. Okay, so we avoid having any downtime on our service. But before swapping, as you can see here in this pipeline, we have a nice load test job. Okay, which is called load test basically, and it needs the deploy to be done. So after the step, the job that deploys the code to our staging deployment slots, we basically run the load tests. This is done using K6 action. It's provided by K6 itself, and it's open source. You can take a look at the documentation page, and we're gonna focus on this a little bit later. But what this does, it takes the loadtest.js file, which I'm going to show you in a moment, and passes a nice variable, which we are calling myHostname. So let's take a look at the loadtest.js file. I want you to focus on the two main parts of this file. The first one is the options, and the second one is the default function. The default function, you can consider this as a main entry point for your load test. Okay, so this is where the code is actually executed, and it's very, very simple. Just makes an HTTP request to get the fast API endpoint. And as you can see, we have set it up in order to use a variable which is called myHostname. Why do we do this? Because we have many different deployment slots, as I told you before. So we don't want to hard code the base URL of our application, because in that scenario, we would have to write many different load tests. But using the variables, we can just write one file, which is going to run for every base URL we have. And in the second part of this file is composed by the options section. So we have the stages. As Ivan told you, K6 generates some virtual user to hit your API or your endpoint. We are not defining specifically the virtual user we are needing. We are just saying, okay, for 10 seconds, hit the API 15 times, and then for 20 seconds, hit the API 15 times. K6 will automatically generate the virtual user we need to do that. And the second part is the thresholds. The thresholds, what we define basically the target we want our web API to meet, or our web app in a different scenario. So we are saying that we want the 90th percentile of request. So we're not considering the average, because we want to meet a more broadened experience of our user. And we want that to be under 250 milliseconds. Okay, so we are going to load our web API with a lot of requests, and we want them to respond every single time under 250 milliseconds. Let's see how this is running on GitHub. So as you can see, we have here our first run, which has built the application, deployed the application to a staging environment, and this is outputting the base URL of our application. So if we hit this and go over here and say, okay, hit the fast API, you can say it's returning hello world. And then we run the load tests. If we take a look at the logs of the load tests, let me zoom in. Okay, we can see that we have the same summary Ivan showed you in the slide before. So the HTTP request duration is what we are considering here, and we can see that the 19th percentile was around 131 milliseconds, so it met the thresholds. And then, of course, the swap happened. Okay, so we have deployed the application in the production slot. But it looks like here I've got a pull request. So someone opened up a request, which was me, called added slow API. This is not promising. And if we take a look, we can see we have some checks that were not successful. So alongside with the the main CI/CD process, which is triggered by the main branch. I've also set it up a PR test, okay, which is triggered whenever a PR is opened or edited and so on. And it basically does the same thing as the one we have for the main branch, but there are a few differences. We define a slot name, which is called PR dash and give a github.event.number. The GitHub event in this scenario is the pull request. So it takes the number of the pull request which was created and create a variable which is called, in this case, PR-5. Build the application, of course, and then in the deploy steps, we first create a PR slot. So we are creating on Azure another deployment slot. You can see it here. So it's PR-5, okay, and we are deploying the application to that slot. After doing that, we once again have the output of our deployment job, which is the web app URL, and we are passing that to the load test.js file. So the load test in this case will run against the deployment slot for the PR itself. So let's see what happened here. As you can see, the load test job was required and it failed. Let's see the details. Okay, as you can see here, the 19th percentile was around 6.7 seconds, which is unbelievable. And the error message says some thresholds have failed. So the thresholds I've defined in the load test.js file failed. Load test know that, and K6 load know that, and makes the pipeline fail. So let's take a look at the commits that were added to this PR. Okay, so the first commit, the first file which was modified was, of course, the load test.js file, in which was added the HTTP request against this slow API endpoint, and it was added this slow API endpoint itself, which sleeps for 2 seconds and then says sorry for the delay, hello world. Well, I don't think you can just say I'm sorry and then being late. So let's switch our branch and go to the branch specifically defined for this PR and switch the thread of sleep to 1 millisecond. This should be enough. Let's commit a fix, reduce wait time, commit and sync our changes. So since we are committing to the branch of the PR, GitHub will know that and rerun the action of the PR because it was edited, and we can see it now running. So first it's going to build. We're going to wait for this PR to close in order for me to have you to witness how the CI process effectively work. Okay. So, okay, it sets up .NET Core because we want a specific version of .NET Core here. It's going to restore the packages, and then it will go over. While this is running, I want to show you what will happen after we have completed the PR. So, since we want to keep everything clean, okay, I've got a post-PR YAML pipeline, which is going to take the same slot name and simply delete it in this, so we don't have those many stages up and running on Azure, and we don't waste money. But why is it important to test the web API before merging into main? Well, I think that Ivan covered it up in the slide, but why do we specifically use a slot? Well, slots are actually easier and faster to create, and in this case, we are also running our load test in the same environment in which the production will run. So it's a more let's say write test, okay, because we are using the same resources which we have in the production environment. So here is deploying to the application. Once this is done, okay, we are going to merge the branch into the main branch. And as I've shown you before, the main branch CI/CD pipeline will be triggered, and we are going to rerun the test. Why is that important? Why we don't take for granted the result of the PR CI pipeline? Well, you cannot be sure that when you merge your branch into the main branch, you cannot be sure that there wasn't any previous commit to the main branch which you don't know anything about, and those commits might have broken some dependencies of your new endpoint. You may rely on something to give you a fast answer, but someone, let's say, worsen the performances of other part of the code, so your endpoint may not run in the same way that did on your branch. So that's why it's truly important to run your test before merging and after merging. So we are assuring the correct expected result is actually delivered to our customer. Okay, so it's deploying, and then we are going to get to the juicy part, which are the load test itself. Bear with me for a moment. I'm going to show you the entire run of this, and then I promise this is the last pipeline I'm going to show you running. Okay, so the run tests are running, and we can see from the logs that it's generating virtual users, okay, and it's running the slots. So it's going to take around 30 seconds, because remember, we have defined 2 stages, 10 seconds and 20 seconds. Okay. So we are at 63%, almost over. And yeah, we are done. Okay, so the HTTP request duration was this time, sorry about that, was this time around 153 milliseconds, which is nice. We have tested our application, so we can go ahead, and as you can see now, we have a nice all checks have passed, and we can merge the pull request. Of course, I am the administrator, so I can do that. Okay, so now that it is done, as I told you before, the main branch is running once again the pipeline to deploy to production, and the close PR is deleting the slog we have created for this specific PR. Okay, this is all nice and well. Okay, as Ivan told you before, K6 is not that much resource consuming, so it's quite nice. But what if the load tests we are generating for a load test were a lot more considered a lot more virtual users? How would you handle that? Because in this case, the pipeline is using the horsepower of the GitHub runner, or if you run it on Azure DevOps, it will use the power of the DevOps agent. Okay, but that might not be enough. So you might want to use the cloud power to do this. Okay, as you can see, this action, which I showed you before, and I'm using in GitHub, which is also available for the DevOps marketplace, the Azure DevOps marketplace, has 2 scenarios: the local test and the cloud test. So the local test is the one we are using right now, which is using the horsepower again of the runner of the pipeline. The second one is using the cloud power provided to you by K6. So you can simply add a cloud true and pass the token for the K6 Cloud API. But what if you don't want to use K6 Cloud? You might have an Azure DevOps subscription, okay, and you might want to use the computational power you have on Azure. So I've also set it up another different pipeline for Azure DevOps this time, which is running 2 main PowerShell scripts. The first one is a run K6 load test, and the second one is quality gate load test. So the run K6 load test PowerShell file, don't be scared by the number of parameters we have here. Most of them are defaulted. I want you to focus on this set of parameters. So this defines the K6 agent image. This is the same Docker image Ivan showed you in the slide, load impact /K6. It's hosted on Docker Hub. It defines a number of K6 agent instances. So this is the number of container instances we are going to create to run our load test. And it also specifies the CPU and memory needed for those containers. And let's go down and see, okay, this is the part where we create the containers. First of all, we set the image, the CPU, and the memory with the parameters we have set before. We pass along the environment variables, okay, so numbers of virtual users and so on. And we, once again, pass the myhost name, which is, in this case, is hard-coded, but for simplicity reasons. Okay, and we are attaching a storage account. So what this pipeline does, it takes the load test.js file, the same one we have here. So with just one file, we are running load tests in many different scenarios. It uploads the file to a shared folder on a storage account, and the containers are going to have access to that folder. So after that, we are running the K6 run script against the script.js file. This script.js file is the load test.js file. Okay, this is going to be uploaded and renamed in script.js, and it's going to export the result in a JSON format, in a JSON file. Why do we do this? Well, we have to, of course, query the result to see if our thresholds are met. And we are using log analytics to do that. So we take the output in a JSON file and we upload that to a log analytics workspace. We do that in this simple line of code. Actually, it should be very simple, but because of log analytics API have a limited dimension of file that can be uploaded at the same time. If the results are too big, we simply chunk it in many different API calls. But it's quite simple. So we post to log analytics the result. And then we have the second PowerShell script. So this once again logs into Azure, defines a query string. So the logtail name is the table name in which the results have been uploaded, and defines this simple query. So look on the table where there is a metric HTTP request duration percentile 95, which is above 600 milliseconds, and count the results. If there is no result, then it was succeeded, else it will fail and throw an exception. This metric we are considering here is the basic name of the same metric we had in the summary in GitHub, but in the JSON format it's called like that. I'm going to show you in a moment in the storage account, because we also upload the result in the storage account. So this should be the last run I did. Yeah, I think 2021, 1020, yeah. Okay, so the summary.json, let's download the file. So as you can see here, we have the script.js file, which was the load test.js file renamed. Let's open up the results. And as you can see, you have the same data you had in the CLI output formatted in a JSON format. And we have HTTP request duration, okay, 19th percentile. This is what we are considering right now. So, okay, let's see the pipeline running. I'm not going to rerun that because it takes 2 minutes, but I'm going to show you a runner I have already prepared. So the run load tests logs into the Azure subscription, creates the storage account if there is no one present before, create the share folder for K6 again if it's not there. Then creates the containers, spins up the container and run. Wait for all the containers to be done, and then it removes the containers. So we don't want to waste our money in containers we don't actually use. So we create them, we run the test, and we destroy them. And after that, we run the quality gate, okay, and see that we have succeeded and the thresholds were met. So that's it for the demo. Back to Ivan for the closure of the session. Thank you, everyone.
Well, thank you, everybody. If you have any question, just pop on Teams and we still have, I think, 3 more minutes. So just feel free to ask any question, and we'll try to answer.
In this time, you haven't the question. Attempt other minutes. Okay. Do you have a new question?
Doesn't look
Ivan?
like. No?
Okay. You have received the congratulation.
Yeah.
Waiting for question, I have approved other would you like to deepen something else?
No, I think this is everything. I might also mention that the same solution I showed you with K6 on Azure DevOps can also be adapted to use to run load tests or written in JUnit, because JUnit will output, when you configure a JUnit load test in the JUnit UI, it will output a JMX file. I think it's that's the extension. And you can adapt the same solution I've showed you for K6 in the Azure Container Instances to run the JMX load test as well. So yeah, Cesare, I will leave the project on GitHub. It's actually open source. I'll try to, I think I can post here yeah, I've answered with the link to the demo.
Okay. Do you want to share your reference?
Yeah, of course. I think let me think about that, because okay, I'm going to show you in the chat my Twitter tag. Okay, so you can go ahead and ping me on Twitter whenever you like. I don't have Ivan's, I don't remember. And I think Ivan is having some issue with Teams, so I will come back to you later and leave the tag for Ivan as well on Twitter. Okay, so you can ping him. Okay. I think the time is over, Gaetano. So if we don't have any question, I want to thank you everyone for attending. And once again, I hope you enjoyed the session. If you have any question, please feel free to comment us and ask whatever you like. Okay.
Okay.
Thank you very much.
Thank you, Tommaso and Ivan. Bye.
Bye-bye.
Bye-bye.
Bye. Bye-bye.